27 for the first, and I'm about to do the second half of the calculator paper we started last week. I'm going to share my screen, and you can see it was this paper. It was level 2, paper 2138. It's the very bottom one on that link from the emails that are on level 2. We got through these questions. I'm going to go to the question we're on. We got all the way through, and I think we got to, I did right at the bottom. So we got to question 3C. So is that going to be around here? Let's have a look. It's different in it. So weirdly, on the left-hand side, it gives you the 16 questions, but when you click into them, we can see that actually it's the number of questions. So we got to, that's 3B, that's 3C, and we did actually do 3. Yeah, so that was 3C done. That was the formula there, that's the formula there. So if we scroll down and start with 3D, so let's go on here. I'm just going to move the mouse a little bit so it's not in the way. So we're going to go question here, 3D, and we're on the 27th, 1st, 25. Okay. A customer buys 28% of 250 candles. Tanya needs to pack the candles to send to the customer. Each candle is sold in a box with these dimensions. So that's the little packing box for a candle. Tanya has a packing case with the internal dimensions of 160 by 160 by 80 upwards. The candles must be packed upright and can be stacked. Can Tanya fit all the boxes in the packing case? So it's asking you basically how many, and I'm not going to draw it 3D, little boxes can fit in a big box. If we did the dimensions, we can do that in a second. So what we need to know is along the bottom, it's 160. Up the side, it's also 160, and upwards, it's 80. Our little boxes along the side is 25. Along the side is 25, and upwards, it's 35. So now we can look at these numbers and think, right, 25, and we can do it actually adding it up. 25, one box, 25, 25, 25, that's 100. We'll keep going, 25 and 25. So we've got 6 boxes, and that'll be 150. So we can put 150 there. And we know because it's the same size on the way round as it is on the way around here, we also know it's going to fit 6. So let's put 6. So we're going to 6 along, and we can also fit 6. We're not going to write all that again. 6 along and 6 wide. So on each layer, each flat layer, we've got 6 along and 6 wide. So that's 6 times 6 is 36. We know we can fit 36 on a flat layer. On the way up, look, it's 35. So we've had another 35. Second layer, we can only fit 2 on because that's 70. We can't fit another one on because that takes over 18 out of the box. So we can fit one layer of 36 and another layer of 36. So altogether, in that box, we can fit 72 candles in. So we've worked back on this question because now we actually need to work out what 28% is of 250 to see if they can fit in. So to work out 28% of 250, we simply switch it round, 250 times by 0.28. We change our percentage into a decimal. We only want, split it into 100 pieces, we only want 28 of them back. So if I multiply it by 0.28, that's the equivalent of dividing it by 100 times it by 28. So we change the percentage straight into a decimal and use that as a straight multiplication. So let me get my calculator open. Sorry, not done that. Should have done. Here we go. So we've got 250 times by 0.28, which gives us 70. So we know that 28% of 250 is 70 candles. We can fit in 72. So can we fit them all in? Yes is our final box because that's the justification. And then show your workings. So first of all, I'm going to say 25 times by 6 equals 150. And then I'm going to put 25 again times by 6 equals 150. So 6 boxes, 6 times 6 boxes equals, oh gosh, equals 36. And then I'm going to put 35, add 35 equals 70. So 36 times by 2 equals 72. So we've done on that working out box, we've shown the dimensions of the box little by little, height, and so we've got 236 per layer. I'm going to put per layer, and not per lawyer, per layer, and then we can put so 2 layers. Oh my gosh, spelling is as good as normal, which is rubbish. Layers. So we've got 72 boxes, and then I'm going to put in here, final bit of workings out will be 250 multiplied by 0.28 equals 70. And that's all my workings out you need. It's 4 marks. We've done the dimension of the box, we've done the percentage, and we've given a justification. That's more than enough. Okay, and that takes us to the end of activity 3, and we will roll into activity 4 for the last part. So let's scroll up. Okay, we've got a drawing one. Sometimes the drawing tools on the mock exams aren't brilliant, but let's see if this one's going to let us work. So he buys, Marcus is a travel agent. It looks like a lamp. He buys a cylindrical rotating notice board to display holiday offers. Draw a side elevation of this notice board. So on my, if I draw on here for a side, looking at it from, not brilliant trying it in 3D, but quickly do it. It's a bit slanted, isn't it? Well, it's going to fall over. It's like the Leaning Tower of cylindrical notice boards. Side, front looking straight at it, above. So side view, because it's cylindrical, that would literally be the side view, the back view, the front view. That's every way you look at it because it's cylindrical. Obviously from above, all we'd see is probably one circle, and then the bottom one there where we're looking down on it, and maybe that one as well, like the little one, maybe. So we're not asking from above, we're asking from the side. So we've got to use the tool on here to draw a shape. Oh my gosh. Let's see if we can use the line, because sometimes that doesn't let you draw them. Oh, it's letting us draw. So we're going to go along there, and I can't make it exactly the same as that because it's going to be quite tricky to get the lines. I'm going to go, oh, I didn't want to go down. And then those of you that have had a practice on this will realize that sometimes the lines don't do exactly what you want them to do. So we're going to go down to there. Then we're going to go along. Make sure we make it equal. I mean, they might not touch exactly, but that's purely because it's quite tricky to get them to work the way you want them to. Okay, so that's that bit, the blue bit. And I've got my little sticky bit that comes out the bottom. Probably shows a wrong. Okay, let's do that one and then do another one. Oh my word. So let's grab it. There we go. And then let's get the bottom one. I'm going to go across the bottom to there. I don't know if that's the right size. No, it's less than that, isn't it? So let's get rid of that one. Okay, let's try again. Line along the bottom. Along the bottom. Oh man, and I'm going to have to try and draw these 2 little bits in there. I might draw them a bit further out and then make them stick together. Oh, I need to do that. A bit further out and make it, then drag it in. There we go. Okay, I would be 100% happy with that. It's not massively accurate. There's a line sticking out here, a line sticking out there, not quite touching, not quite touching, not quite touching. But with the tools you've got available in an exam, that is absolutely all you need to do. It's clearly a view of that cylindrical rotating notice board from the side. I could see that it equals that. That's not quite in the middle. Maybe I'd move that a little bit to the right, but it's just really difficult to move those tools. And with the time you got, it's worth 1 mark. So as long as they can see a resemblance of what you've done, absolutely move on. Next question. Question 4b. Marcus reads an article about overseas visitors. 8.4 million visits were made overseas in April 2019. 0.26 million visits were made overseas in April 2021. Work out the percentage decrease in the number of visits from April 2019 to April 2021. So when we're talking about percentage decrease, that one phrase there, when we're talking about, we're thinking of this formula, and the only reason I think of the word no is because that gets it the numbers in the right order. So the N stands for new, and the O stands for old. So the reason we have it thinking of no, when we're thinking of percentage decrease or increase, is because it means we get these in the right order. Once you've remembered the word no, we're going to put new, take away old, divided by old, times 100. So if you look at the word here, no and no, hence why, if you remember that one word, no, you'll start to put that in the right order. Obviously, the minus and the division bits are the things you need to remember, but thinking of the word no gets you the numbers in the right order to start with. And then we times it by 100 to get our percentage. So if we didn't times it by 100, that's the decimal, but we want it in order. Okay, so we've got new 0.26 million. I'm going to sneeze. Oh no. So 260,000, because 0.26 million. I'm going to sneeze, sorry. Excuse me. Take away 8.4 million. I don't think we can use a calculator on this, so we can write it all out. Divided by 8.4 million times 100. So that looks like it's going to be a crazy sum, but let the calculator do that. We can see what it's going to be. So we're going to go 260,000. That's the new number. 1, 2, 3. Take away 8.4 million. 1, 3 equals. That's the top part done. Divided by 8, 4. 1, 2, 3, 1, 2. So that gives us the decimal place. And then we're going to times it by 100. Equals. So as you can see, we've done that, take away that, divided by the same number times by 100, it's minus 96.9%. So if you remember, I mean, that's obviously like a COVID related question, isn't it? Because overseas visits just after COVID was 220. Percentage decrease, we've gone from 8.4 million to 0.26, and it's 96.9%. Does it say a whole number? No. I'm happy to keep it at 96.9. And I think also they would accept 97. So it doesn't matter which way around you do it. I'm happy with the exact percentage. We round it up to one decimal place. We round it up to the nearest whole number. We've got 97. Spaceman working for 2 marks. I'm going to do exactly what I wrote in there. 260,000, 1, 2, 3, minus 8, 1, 2, 3, 3. Divided by 8, 1, 2, 1, 2, 3. Times by 100 equals 96 point something and lots of different numbers. 96.904. Minus 96. Oh yeah, do we put minus? I think minus 96.904. Yes, percentage decrease, but it's not a max. And again, I think when we get to the answer, if you've put minus 96.9, that's absolutely fine as well, because it's decreased by 96.9%. So it's at a minus 96% swing in the numbers. If you put 96.9 percentage decrease, that's absolutely fine as well. So I will wait till we get to the answer for that one, and I'm sure it will give you either or the minus you can put in there, and you'll also be able to put 97 in there as well. Let's scroll down to question C. A 4 mark, a bit more involved. Straight away, when you see the equal to and less than, we're thinking of our lovely friend frequency table. And with frequency table, it's worth 4 marks, so it's definitely one that's going to be more involved than just doing the frequencies, but it's the process. The frequency table process is always the same: midpoint, total. So we've got the midpoint. We add the first and the second number, so 0 add 10 divided by 2. That's 5. Then we multiply it by the number we've got here. And that's the first total we've got. Okay. Second one, 10 add 20 is 30. Divided by 2 is 15. We multiply it by the number of times, 21. 20 add 30 is 50. Divided by 2 is 25. Times by 8. And then 30 add 40 is 70. Divided by 2 is 35. So we always do both the numbers added up together, divided by 2 to find the midpoint. Sometimes it'll say like 10 and 12, so you know it's 11 without having to think in your head that add that. But when it's two numbers like that, and we times that by 3. So once we find the midpoint, we times it by the number of holidays. So there, look, people have gone on holiday between 0 and 10 days 18 times. So we have to estimate that has been a 5-day holiday 18 times, a 15-day holiday 21 times, and so there's a total of 50. So we've got our total here, and we're going to do it in a minute. We'll divide that number by 50. So it's like hence the mean frequency, the mean estimate. So we've added them all up and divided by total number of occurrences, which is 50. So let's work out our numbers here quickly. 5 times 18, because it's going to be more to do with it than that. So 90, I don't know how to do that on a calculator, but it's just laziness. 15 times 21, as long as you punch in the right numbers and you're confident. Sometimes my computer calculator is a little bit iffy. I prefer a real calculator, but it's harder to show you on screen what I'm actually doing. 25 times 8, 200. 200. And then 35 times 3 is 105. Again, use your calculator to be confident, to be sure. And then what we do, we add all those numbers up to get our total, like you would on a mean, normal mean. So that will be our total. Add 315, add 200, add 105. Okay, so that's then a total number of days of 710. So for all those holidays, 710 days holiday divided by 50. 50, saying that on average, people took a holiday for 14.2 days. Right, so let's get rid of the calculator, see what else. That's not going to be the end of the question, I know it. In March, the estimated number of mean days for his clients booked packages. Right, so in March, the estimated mean number of days his clients booked package holidays was for 9.41. This is April. So if you think about, that's April. All right, 9.41 was March. Marcus thinks the estimated number of mean days for April is over 1.5 times greater than the estimated mean number for March. Marcus thinks the estimated mean number of days for April is 1.5 times greater than March. 9.41 is 1.5 greater, 1.5 greater. Is he correct? So that's the important part there. So that's the bit at the end where it's give us a little bit more math to do. 9.41, which is March. He thinks April is 1.5 times more. 1.5 equals 14.115. 14.115. Is he correct? If we say we had 14.2 for April, scroll down a wee bit. 14.2 for April, that is greater than 14.115. Not by much, but it's not the amount that counts. Is it or is it not? It is. So is he correct? Yes, in our box at the bottom. So let's put here, estimate 4 marks. Would I be tempted? I would be tempted actually to go 5 times 18. Add, which is what, 90, and then I put 15 times. This is where your time gets eaten up by, but you might have done this as you were working on. I didn't put equals in there, did I? Equals. Then we've got, that's 315. Then, oh God, 3,104. Then we've got 25 times 8. 25 times 8 was 200. Then we've got 35 times 3, which is 105. 105, that equals 710. Then we divide 710 by 50, and that equals 14.2. 14.2, and then we've got 14.2, not 14.2, 0.41 times by 1.5 equals 14.115. And that's our answer. We've got those numbers there that signify that April is 1.5 times greater. Let's scroll. Next question. Olga books a holiday resort in Spain. She hires a car to drive from the airport to the resort. Marcus gives her a map showing the airport and the resort. Olga knows the scale is 1 to 125,000. So in the map, 1 centimeter is in real life 125,000 centimeters. We're talking centimeters. The distance along the road between the airport and the resort on the map is 51.2 centimeters. So here we go. 51.2 centimeters is the map. She will drive at an average speed of 80 kilometers per hour. Work out how long it will take Olga to get to the airport. So there are a little bit to remember here is that the triangle is always the same when it comes to any question to do with distance, speed, or time. We're going to have the distance because we're going to work out here in centimeters. We'll change that to kilometers. And we've got the time, or we've got the speed. So we're going to go distance, and that line means divide by speed equals time. So we've got all the bits we need. That's the only bit that you need to remember from that revision sheet is the distance, speed, time triangles. And you remember the D's on top, the other two at the bottom, don't matter which way around they go. So we know it's 51.2 centimeters. And you can see here, look, the relationship between this one and this one is times by 125,000. I can't really squeeze that in. 1, 2, 3. So we need to do that same with that one. Or if you prefer to do it the other way around, so you do these two around, if you notice that distance there, that's times by 51.2. So we times that one by 51.2. Doesn't matter which way around you do it with direct proportion, as long as it's one or the other. Right, so let's scrub both those out for now. And let's work out what it would be. So we're going to go 51.2 centimeters times by 125,000 centimeters. Now, don't forget. So my workings out here was 51.2 times by 125,000 equals 6, 4, 1, 2, 1, 2, 3 centimeters. So I went this way. I know, I think for me, I see that relationship. Oh, it's 125,000 times bigger than that one. So this one also needs to be 125,000 times bigger than that one. Had you done that way around, it's still exactly the same number. Okay, so we've got centimeters, 6, 4, 0, 1, 2, 3, 4. How many meters is that? We know in centimeters is 100 for 1 meter. So I'm going to divide that number first by 100 to get my meters. Divide by 100. 1, 2. So I know it's 64,000 meters. And then in each kilometer, so 1,000 meters equals 1 kilometer. So if I divide that by 1,000, I would then get kilometers. So those are the bits that we should know. We should know that there's 100 centimeters in 1 meter, and we should know that there's 1,000 meters in 1 kilometer. Kilo being the operative word, kilo, 1,000. Okay, 64. So we know it's 64 kilometers. Distance traveled, 64 kilometers. That now gives us, if we move that out of the way, we've got, she travels at 80 kilometers per hour. We now know she's gone 64 kilometers. We've now got the same digit. We've now got them both in the same digit. If we scroll down, look, the D, distance, 64, divided by speed, 80. Okay, we've got them in the same number. So we've got the distance, 51.2 centimeters. We've changed it now up to centimeters, meters, kilometers. So we now know that that number represents 64 kilometers in real life. They've gone 80 kilometers per hour. So let's divide 64 by 80. And we can see it's taken us 0.8 hours. Okay, 0.8 hours. Is that enough? Potentially, they might say that's enough. But if we want to work out 0.8 of an hour in minutes, so 0.8 times by 60. It's going to give us the time in minutes, or 60 times 0.8, whichever way around you want to do it. Times by 60. We know that it's going to take her 48 minutes. And I would be looking as an examiner for that number. If you put 0.8, we'll have a look in a second or in a few minutes if they accept 0.8. But I will be still looking if it says 0.8 of an hour. I'm looking to change that to minutes, because 0.8 of an hour to most people doesn't really mean a great deal. 48 minutes, oh yeah, no, 40 minutes, it's more than 3/4 of an hour. It's not quite an hour. But 0.8 of an hour, I'm thinking, don't really know how much that is. So 100%, how long it take her? I'm putting 48 minutes in there. Let's put space of work in. We said in here, 51.2 times by 125,000, 125, 123 equals 6.4 million. 6.4 million divided by 100 equals 64,000. 64,000 divided by 1,000 equals 64. And then we've got 64 divided by 80 equals 0.8. Oh, 0.8. And then we've got 60 times by, because there's 60 minutes in 1 hour. So we do 60 times by the decimal, which is 0.8, gives us 48 minutes. Okay, that's that question. For 3 marks, I think that's quite involved. For 3 marks, we've got a lot of converting to do, but we got there in the end. It's just the process, isn't it, of knowing centimeters into a meter, meters into a kilometer, and remembering the distance, speed, time triangle. Okay, next question. 2 marks. Marcus records the number of different holiday bookings made by his clients in 1 month. What is the probability that a client chosen at random is a new client that booked a flight and hotel holiday? Give your answer as a decimal. So we're not asking for a fraction. This one's actually specifically said a decimal. So when we're looking at probabilities, we look along this number. So probably is a new client. So it's any of these. Okay, he said a new client that's booked a flight and hotel. That's 19 people. And it's at random. So it's not just chosen new clients. It's chosen a client that's new and a flight. So we've got to include the returning as well. So it's out of everybody, he's got 19 chances. So if we add all these numbers up, that's 18, that's 30, 39, 49, 58, 88, 90. So our fraction is he's got 19 chances in 90 of choosing a new client, booking a flight and a hotel. That's the fraction. Fraction to decimal, we do exactly as it says there. 19 divided by 90 equals our decimal. And if we wanted to do a percentage, we'd then just times that by 100, but it doesn't ask for that. It says 19 divided by 90 equals 0.21111. That's 0.2111111 forever and ever and ever and ever and ever. Okay. Your answer is the decimal. So we've put here 19 divided by 90 equals 0.211 forever. As a decimal, I'm rounding up to 0.21 because it's 111 forever. It's not going to ever stop. So we're going to put 0.21. We've rounded up to 2 decimal places. Sensible. Okay. We could carry on writing forever number 1, but we won't. We'll put 0.21. And again, the answer might even let you put 0.2. We'll have a look at that again when we're finished, but sensibly we'll be rounding up to 2 decimal places. The last question for a 1 marker, and it's two separate questions. Look, we've got a 1 pointer at top and then a 2 pointer. Okay, Marcus has this information about the number of bookings made in the first 6 months of 2023. He wants to compare these bookings with those made in the same period of last year. Use the table to compare. Notepad, I don't need a notepad. Right, Marcus has information about the number of bookings made in the first 6 months of last year. He wants to compare these bookings. What's the question? Interesting. What? Use the data to complete. Oh, to complete the table. Okay, complete the table here. I get it now. I was thinking, what's the question actually asking? Okay, so we've got here. It's done the mean for us. That's the easy bit. The mean, where you add them all up, divided by number of occurrences. It's asking for the range. So what are the range of those numbers? We go highest, take away lowest is the range. The lower the range, the closer the numbers are together, is the more consistent. Let's have a look. So the highest number here is 92. The lowest number here is 60. So the range is therefore 32. So we complete that, stick our 32 in there, and that's the table complete for 1 mark. Again, it was a lot of writing for just saying work out the range for the table above. Done. I understand that. I can do it straight away. I've figured it out, but I've read this table, I've read that table. I'm like, well, it's sometimes a bit all over the place. Right. Use the table for question. So use the table here. Compare the mean and the range bookings in the first 6 months of 2023 with the mean and range bookings for the first 6 months of 2022, and provide some statements. Mean comparison. That's quite easy. For me, we're talking in 2023, right? So 2023, the mean was higher than that of excuse my rhyme, by the way, 2022. I should just type it. Oh, silly person. That mean in 2023 was higher than that of 2022. And I'm putting here 2023 was 678.5 and 2022 was 63.7. Okay, that's my comparison. It's higher. I've told them which one's higher. Comparison for range. They are looking for the word consistent. Or if you say that the range in 2022 was 27, which is lower than the range in 2023, they'll probably accept that. But they're really looking for the word consistent to be used. And we can see the consistency in 2022 was more because it's a lower number, so the numbers were more consistent, they were more compact. So I'm going to write in here the range in 2022 was more consistent than, first of all, right, than my word, than in 2023. 2022 range was 27. And in 2023, it was 32. So we've put statements in there. We've clearly said which one is the highest. There's no why with averages. It's just because it is. We've done the maths. But the word consistent's in there. Happy with that. That's what they're looking for. And that will be the end of the test. If we can quickly, we might be able to go through the whole of this and use my marking for one part. And then my work is outside for the first part, and then the actual test paper for the next part. Okay, so let's scroll up to the very top and then scroll down to the calculator part on this one. So let's get right into, so activity 1 is the non-calc. So when we go to activity 2 is when the calculator starts. So here we go. Section B, which is a calculator test, it says there. So the angle, I remember doing the angle a few days ago. It was the flat line angle is 180, so we have to divide it. We'll have to add up to 180. There was already one angle in there, so we take that away. And it was a symmetrical shape, so we can divide it by 2. So 72.54, correct. 2B, working in meters, 1.1. Where's the answer at for this one? I should have been more clear. Where have I got my answer at? 32. 32, 32. Are we looking for 32 anywhere? 32, 32. I've got 32 there. That's quite difficult because I don't really remember. Oh, 57.95. There we go, 57.95. Then do I add something on there? Yep. So, okay, I get it. So 32 was my number of, I changed feet to inches, meters to feet. Then I've got the median price. I'm trying to remember. It was the shop put one, I think. And then we've got the median price times by the number of meters. So 32 times by 57. Yeah, so we've got that. And so we have 18481. Oh, why have I not got that? 50. I done it wrong on my calculator. 57.95 times by 32. 18. Oh, they've rounded theirs up to 32. Okay, so we didn't round ours up until the end. I'm sticking to pounds and pence until the end. So £1,954 40p. So they've rounded theirs up. We didn't. We kept it accurate. And yes, supported with correct working. We've got the correct working all the way through. So answer would be absolutely fine at that. They've just rounded it up to. It's £6 less. But yeah, we've kept it accurate. Let's go C. We were asked to say whether it was a positive or negative correlation. I think rectangle drawn. Where is C at then? So was there not another one? Why have we got positive, negative for correlation? I thought that was to do with the distance he was throwing the shot put. Oh yeah, it was. Yeah, that's part D though, because question C was the drawing one. Sorry, question C was the drawing one. We had to put the running track on there. As you know, on that on the practice paper, the actual lines don't stick. And so in that session, I was saying if that's me in the exam, there's a camera watching you here, and there's a camera watching you from behind, which is your phone. If you're commentating, obviously not talking to anybody in the room because you're on your own. But if I'm saying I'm clicking on the pen, I'm putting it at, 5 squares from the bottom, which is 10 meters from the running track, and I'm making my track 1.5 squares wide, which is 3 meters. I'm drawing it by 16 squares, which is 32 meters, and it's not sticking, and they can see that, then you're going to get full marks for that. You aren't responsible for technology failing you on the day. If you've just spoken for it, it don't work, next question, you won't get the point. But if you try to draw it a couple of times and it's not like we're doing it and it didn't stick, but we've spoken through and we've said how big that distance is on the map and in real life, because it was one centimeter or 1 square equal 2 meters, then they can clearly know that what you're talking about is exactly what you will be drawing. So that's why we did it that way. We spoken through it, it didn't stick. Okay, then we said negative. Okay, we've got upward hill is a positive. You're on things are on the up, and then things are on the down. So negative, it was on going down from left to right, which was negative. Then we did the full question where we spoke about the actual pounds to kilograms with the shot put. If he was throwing a shot put weighing 7.2 kilos, it would be a negative score. We can't throw a shot put -1 meters. We can't throw it behind us. So on the trajectory using the graph, it was stating that he wouldn't be able to throw it that far. He would be throwing it a negative. Look, the line predicts a negative length, which is impossible. We can't do it. So that's why we couldn't use that graph. It says, why can't you use this graph to predict how far he's going to throw it? Then we've got here, I'm looking for the matching here, 550 divided by 90,000, done that times by 100, 5.444. Why does ours that say 6.11? Checking here, 0.6. Why have we got a different number there? Interesting again, is that? Okay, maybe 2F is a different one as well, though. I've got it here, look, 2.F, not remember one. Let me just work that on a calculator because I've got, maybe that's the next question. So look, 550 divided by 90,000, 123 equals times by 100. Okay, I would have written that in. Yeah, because that's the next question. That's 124. Okay, so again, sometimes with my workings out, because I didn't write everything on my workings out, I was trying to put in an electric box. It's kind of a bit of a mismatch there. So with the next question was talking about 124 of 125. So there's a fraction 124 over 125, which is, like we said, 5.44. Done that exactly the same. We round it up to 5.5. Yes, they round to 5.5. It's a little bit harder when it's not live and you're kind of thinking, what did I write 3 days ago, 4 dadays ago? Then we've got the next question here. We're looking for a number of no, so it's no, and it's 5472. Oh yeah, 5472. There we go. It was a no because we're looking at the temperature, the price, sorry. Then we've got the little, I made it into a primary school window where we're working out direct proportion. So we've got here what we got here, 3.72, 3.72, 3.72, where we've got anywhere 3.72. Just try to find the right question. 4175. So we go right down here. We use a little conversion to kilograms. We've gone down and we've got 4175.7 using that formula that was working out. Gosh, what was it working out? Like this formula here, the volume of something, I can't remember what it was. Was it a cylinder? We've got the formula there, and then we've worked it out as 4175.70. 475.70. And then we've got today's work. Thank goodness we can now look at today's work, which was a little bit more in the memory bank because we did it just today. So we've got comparison of sizes. Can we flip our page open to here? I'm hoping I can now put that one on that side. Just question 8, was it? Nope. Question 10. Yep. Question 10. There we go. Now we're okay. Now we can compare what we've done. So yes, it fits 72 boxes as opposed to 70. Yes, we had 72 boxes as opposed to 70. Absolutely correct. Then we jumped into 4A because that was the last question on that activity. Drawing the lamp. As you can see, my masterpiece there is pretty much the same as their masterpiece. They've coloured theirs in. We don't need to colour it in. There's no colours available on here, so there's absolutely no reason to colour it in whatsoever, but they have, which is fine. 3 rectangles with a bottom rectangle narrower than the top rectangle. That's what I was saying about this part here. So 1 rectangle, 2 rectangles, 3 rectangles, and we've kind of got it sussed. Right, next question. 96.9. 96.9. Accept any correct rounding. So they're accepting 97. Accept any correct rounding. As long as you've been confident with your math that you've done here, they've accepted it. Let's scroll down. I'm trying to figure out if they've accepted minus. Correct any full correct. I think they would have. I think it would have been minus as well. They'd have accepted that. It doesn't say it here, but again, quite often if you've got the right numbers, it is a minus 96.9% decrease. It's gone down. But you know, we put 96.9. We didn't round it to 97, but it has accepted any rounding. Let's go question 13. The frequency table. For me, we did the little bits here. Look. We showed that part. That's the first mark we got. We got to 710. We divided it by 50, so 14.2. That's mark number 2. Then we've got timesing it by 1.5 for mark number 3 to show the comparison, and then we've got mark number 4 saying yes because 4.2 is larger than 14.115, and that was that mark there. Question 14. And that's quite confusing as well. This is 4C, that's 4D. I guess a bit 0.8 hours. So they would have accepted 0.8 hours here. We convert it to minutes purely because I think it looks neater. And I think, like I said before, when somebody says to me, oh, it's going to take you 48 minutes, I kind of know. So it's going to take me 0.8 hours. I'm like, it's less than an hour, but I'm not really sure what 0.8 hours is. So me, 48 minutes is definitive. We know. I'm getting a taxi ride. It's going to take you 0.625 of an hour. Oh, okay. Or it's going to take me, 38 minutes. Oh, right. I know what that is. So yeah, for me, the minutes part is important, but not to the examiner. So it would have mattered not. 0.21 was the probability as a decimal. 0.21 as a decimal. They've rounded theirs up. Yeah, they've put the brackets on there because they've shown they've worked it out. Accept rounded value to at least 2 decimal places, because that's where after the third, the fourth, the fifth, the sixth, the seventh, that's where the number stays the same. So they've accepted it to 0.21. Question F, the last question, we're talking filling in a table. We filled in the missing link on the table 32, and then we put in the 2 different statements. One talking about the mean, which was higher in 2023. Valid comments compare means as if the mean of the bookings is higher in the first 6 months of 2023. Done. Have they used the word consistent? Right. The must-seen comment must relate to the spread. Example, the number of bookings per month is more variable, or the range is less consistent in 2023. Do not allow the range is higher. We didn't write the range was higher. We wrote that the number of bookings in 2022 was more consistent. So we have the correct answer there. If you'd have put the number of bookings in 2023 were less consistent, that's the same as writing they were more consistent in 2022. So it's the same way around. It's just saying that 2023 was less consistent, 2022 is more consistent. Well, it's the same statement, but you've just changed higher in 2023. And that's the end of the exam. Let me stop the recording and stop the sharing, and I'll get this published today. We'll start a fresh one this afternoon, and we'll look at the next paper up for Calculio. Thank you very much.